Choose 2 points on the line and then use them to find the slope. Write the slope in decimal form rounded to 2 decimal places. To calculate the slope, we'll use the slope formula m equals the quantity y2 minus y1 divided by the quantity x2 minus x1, where the ordered pairs x1, y1 and x2, y2 are any 2 points on the line. While we can choose any 2 points on the line, it's easier to identify the x and y coordinates when the point is at the intersection of 2 grid lines. For example, here is a point at the intersection of 2 grid lines, and here's another one. Now we need to label the points with their respective x and y coordinates. To do this, we need to know the scales for the x and y axes. In other words, we need to know how the tick marks increase on each axis. But on this graph, the tick marks on the axes are not numbered. Whenever the numbers are missing on the axes, we assume the values increase by 1 to the right of the origin along the x-axis, and we assume the values increase by 1 above the origin along the y-axis. Similarly, we assume the values decrease by 1 to the left of the origin along the x-axis and decrease by 1 below the origin along the y-axis. Okay, we're ready to label the points. Let's start with this one. The x-coordinate is always listed first in any ordered pair. So we start at the origin and move left in the negative x direction until we get to the place where we need to turn. We count the number of tick marks along the x-axis to get x equals -4. Next, we make the turn and move up in the positive y direction and stop at the point. We count the number of tick marks in the positive y direction to get y equals 3. We're ready to label the xy point where x equals -4 and y equals 3. Now we repeat the process to find the coordinates of the second point. We start at the origin and move right in the positive x direction until we get to the place where we need to turn. We count the number of tick marks along the x-axis to get x equals 2. Next, we make the turn and move down in the negative y direction and stop at the point. We count the number of tick marks in the negative y direction to get y equals -5. We're ready to label the xy point where x equals 2 and y equals -5. Now we substitute the x and y coordinates from both points into the slope formula. M equals the quantity y2 minus y1 divide by the quantity x2 minus x1. We need to be careful though. A common error is to confuse the subtraction signs in the slope formula with the negative signs on the numbers we will substitute into the formula. So to practice safe math, let's set up parentheses for the substitutions so that we clearly separate the subtraction signs in the slope formula from any negative signs on the numbers we will substitute into the formula. In the numerator, we substitute y2 equals -5 and y1 equals 3. And since we started the substitutions in the numerator with y2, we must start the substitutions in the denominator with y2's partner, x2. So in the denominator, we substitute x2 equals 2 and x1 equals -4. Next, we calculate -5 subtract 3 equals -8 in the numerator, and 2 subtract -4 equals 6 in the denominator. So the slope is -8 divided by 6. To verify the slope is correct, we can trace the rise over run map from one point on the line to the other. Beginning at the point, -4, 3, we move down in the negative y direction until we reach the intersection where we need to turn. We count the tick marks and learn that the rise is indeed -8. Then we turn and move right in the positive x direction until we reach the second point. We count the tick marks and learn that the run is indeed 6. So our calculations were correct. The slope is -8 divided by 6. Finally, we were directed to find the slope rounded to 2 decimal places. So we calculate -8 divided by 6 to get m is approximately equal to -1.33.